Hello everyone, welcome to my channel. This is Basu and today I will be showing you how we can stream data to be more precise, stream sensor data to a popular IoT platform known as Tweet.io. So we'll be having a light sensor, we'll be having an Intel Edison. Although we are going to use Node.js for all the programming for capturing the data and uploading to the cloud. However, you might have learned that Intel Edison might not be available in the market in the upcoming few months. However, the devices that supports Node.js will also support this particular piece of code, or this particular piece of the process will be more or less similar for us to stream the data to the to Tweet.io. So we have the light sensor, we acquire the data using Intel Edison, and we then stream the data to Tweet.io. Finally, we visualize the data into Tweet.io. So let's just get into what is this Tweet.io. So Tweet.io is an Internet of Things platform which provides us to stream the sensor data. It's free if you are streaming it publicly, while if you are streaming in privately, then you have to pay for it. However, not interested in private Tweet.io. Let's see how we can use it. So once you go to a home page, you have to click on play tab. So once the page gets so before coming to Tweet.io, let me just say you, there is a npm dependency that can be used to simplify the entire process of streaming the sensor data to Tweet.io. So the package's name is node-tweet.io. So use the npm install command to install the package on your Intel Edison. It will be something similar to npm install tweet. It was something else, I guess. So this will install all the dependencies, all of the dependencies that are required. Now let's head back to Tweet.io. Okay, so here if you just navigate to Tweets, you will see post/tweet/for/thing. Now we are interested in this particular section because we will be creating a tweet for a particular thing. Let's name a thing as light test. Now be very specific about the name of the thing that you give it, because this will be used in your program. Now just click on try it out and wait for a few minutes or some seconds. So once you get the request URL and the response body, that means it's working. Yes, and to check whether you're receiving an incoming message or not, you have to click on the discover button. But however, we are not at any code, so right now we'll see what the code looks like and how we wrote the code, and then we'll move towards the visualization of Tweet.io. So the code is extremely simple, very simple. We have used another dependency as JSUPM_grove. This is for the obtaining the light sensor reading in lux. Now if you can also go for directly acquiring the sensor data by simply using analog read function, but that will provide you raw value, and converting a raw value to the standard international unit or SI unit can be a bit more tedious job, because we need to find the load variables, load resistance values and lots of other stuffs, and then through a graphical interpretation we can only come out with a formula for converting those raw values to the standard international unit. However, they have provided us a set of libraries thanks to Grove by Seed Studios. So I am using that particular dependency for getting the the desired value. So we have to create a Tweet client, and then we have already created a Tweet client named as Tweet.io. We are obtaining we have created a light object which is group sensor, the class type dot group light, and we have mentioned the pin number. Our like the sensor is connected to analog pin 0, so we have mentioned it as 0. Now we have created a function as do it send. In do it send, we have to use do it io dot do it underscore for, within bracket mention the thing name which we have just now created, and within the parenthesis pass the light intensity, which is the name of the parameter, followed by the value. Now light was the object which we have created for the sensor module. Dot value. Now this dot value will return you the value in lux, that is a SI unit. So once you get that, we are just printing it in the console, the value that we are sending, and we have set up a timeout of 10 seconds or 10,000 milliseconds, and finally we are calling in the function. Transfer this code to your device using FileZilla, and now let's run the code. Node.js Edison.js. So once you run the code, you will see every 10 seconds a value will be updated in the console. Similarly, now let's head back to the do.io Internet of Things page. We have created a thing. Now we click on play. I think I have already clicked on. Yes. So here I am getting the light intensity values. So just reload this page. Sometimes it takes a bit of time. So the last value that was recorded was 6. Now let's just wait for 10 seconds and see the next value that comes. So every value is 6, so I have to just provide some extra source of light. Yes, 24. Yeah, it was 24 out here, I guess, somewhere. Okay, we'll check that later. So in raw, if you click on the raw tab, we'll see the value that the Intel Edison is sending is in a JSON format, with light intensity being the key and 5 being the value. Now we want to visualize this data in a standard form of gauge. So there's another IoT platform for visualization known as freeboard.io. So it also, the freeboard.io and mint.io falls under the same company. So we don't really need to worry about patching these two together. So just log in, or if you are like signing up for the first time, just click on start now. I have already created 3 boards. However, I will just create one more. I have already created here, do it YouTube. So I'll just create it, do it, click on create new. Now once you come to this page, you have to add a data source. Now click on add button. Now select a type. So here the type will be do.io. So type in the name. The name will be the name of your thing, that is light space test, and the thing name will also be the same, light space test. We don't have any keys because it's public. We click on save. Now once this is done, we'll just add one pen. Now in the pen we'll add one gauge. In the gauge we'll give a title such as light intensity, and we'll provide a value that is from the data source. So we'll click on this light test, and again light intensity, that is under the thing light test we are having a parameter light intensity. So we provide that. The unit will be in lux, minimum 0, maximum 100. So just click on save button and it should be done. Yes, you are having a live feed of your sensor data to do.io, and from do.io we are visualizing the data in freeboard.io. So let's just check whether by giving more light to the sensor, I hope the light is okay. So I'll just check the console. Yeah. So again wait for 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's switch off this. Sometimes it's a slow process because we are using a completely free service, that also non-public, I mean public. So sometimes it might be extremely laggy, but this is one of the best free way to stream your data to an IoT platform and then parallelly visualize the data in the IoT platform. So that's how the entire thing works. So just to have a recap of the entire thing, we have a light sensor. We have connected Intel Edison to the light sensor. Then we are streaming in the light sensor value using a Node.js code to Dwit.io. Now in the code we have the declare group sensor Dwit client Dwit.io, and in the function Dwit send we are sending it as a JSON file with the thing name as light test, which was created initially. Now once the code is running, you will be seeing your data getting streamed to Dwit.io, and from there you will see the data. If you want to go for more visualization, then you can see it in freeboard.io. That's how the entire thing is functioning. Thank you for this video. If you like this video, please hit the subscribe button, and in the upcoming week I will try to make some videos about mainly on calibration of sensors, and I will move more towards the hardware side of the IoT and robotics. So I will see how we can acquire data from multiple sensors, how we can control motors using motor drivers and all those stuff. It's going to be interesting. Like the upcoming weeks are going to be interesting if you are more on the hardware side. Else this was for today. Thank you and see you soon.